Hi everyone, morning, afternoon, evening. This is Pranay from DBS Diary. First of all, I would like to thank each and every one of you who has subscribed to my channel. It has already reached more than 900. I was not expecting this much, but thanks to all of you who liked my video and they subscribed and they also shared with their friends. Thank you very much. And uh, I would again request you to like and comment in case of any question, and if you want something else to cover. I know this video I have been recording after a long time, but my work was really hectic, so didn't get enough time to record more videos. However, I have learned a lot of things in recent few months, so I will be recording more and more videos in the next few days. So just keep tuned yourself towards my channel. I have also prepared a list of questions for replication interview, and I'm sure if you manage to answer them, you will be able to crack any interview for Sybase replication. Okay, so please keep liking them and do comment in case of any question, or if you want me to cover something else or something in more deep and detail, do let me know, and subscribe to my channel so that you will be aware that what all things I am covering, right? So today very basic thing we'll cover, and that is performance tuning of Sybase. And it's not limited to Sybase, but it's about locking scheme and all, and how does it really help and deadlock. So it sounds pretty simple and basic, but when you really work on some SNP environment and you have OLTP environment, you see that how important it becomes. Okay, so very first thing that you should do is to enable checking deadlock. Okay, at many environment you will see it's not enabled, so I will just put that in the comment like how to enable it. So ensure that the checking deadlock checking is very much enabled. However, the frequency of checking should not be too less, because when optimizer checks for deadlock, it puts pin lock on the engine, on the memory. Okay, so should not be too frequent. It should be once in a while. I will mention that as well in the comment how frequently you should check. So when the when the deadlock is captured, so it's very good. You can see there allow the detail of deadlock. Okay, what is the victim, which one has been killed, and it's very straightforward. You can check if something has been no victimized, that means it has been rolled back, it has been killed, right? And then if it is waiting for a shared lock, that means that table must be having all page locking scheme. So first thing that you should do to avoid deadlock is to change the scheme from all page to data page or data row. Now you can ask me what is the difference in all page, data page and data row, right? So you can refer it. I mean, it's a very straight and simple thing to change your table locking scheme from all page to data row mostly, or in some case data page, right? Now how does it really impact? So it again depends, like what is your environment, is it OLTP or OLAP? So do you do more of read operation, or you do more of write operation? That's what I'm trying to say. And what is the volume of data? So if you are reading too frequently and writing it once or twice, or maybe couple of times, but the frequency of read is much higher than what you do write operation, so then you should change the locking scheme from all page to data page or data row. Now when I talk about data all page, so all page means the leaf node. It's not only data page which is locked, but also the index page has been locked with exclusive lock. So index page has been locked with exclusive and data page. That means any new operation, and this lock is held until the end of transaction, right? So when you do any transaction at that point of time, so if you already have a update going on, or insert going on, or delete going on, right? That time if something else comes up, so since at that point of time data page and index page, both of them are having exclusively locked by some other process, you may not get access to that. That's when you will be having deadlock. But deadlock will happen only when there are cycle dependency, right? But if the deadlock is happening, that means you already have many more blocking in the environment. However, there is no mechanism to capture blocking in error log, but you have to understand one thing, very simple thing, that if there is deadlock, that means blocking is already happening. In case you have monitoring tool, okay, there are many monitoring tools available. In case you have it configured there in your environment, you would be able to capture them as well. However, just to understand, as I said before, if you can fix deadlock, you are not only fixing deadlock, rather you are fixing so many blocking. So if you fix deadlock and blocking both, that means the performance of your environment, of your database is much more than what it was. So I explained about the all page. So in all page, as I said, so you have locking on both, exclusive lock on the data page and the index page. In the case of data page, so before it was all page, so both were locked, now data page. In the case of data page is still locked with exclusive lock, but index page is not locked with exclusive lock. Index page, there is a latch held. Okay, latch is something, there is difference in lock and latch. I have explained in one of my previous video. You can go through that. I will give the link also. So latch is something which is held for very, very less period of time compared to lock, and it releases the modular lock, or you can say it is only for the physical consistency of data. That is released very fast compared to lock. So now you need to understand one more thing before we go into all page and data row. So this is held at the leaf level, right? Now the another thing is when you create an index. So if the table is having, suppose for example 56 column, right? So index will not have more than 2, 3 or 5 to 10, maximum 10 column, right? If I don't think you can have an index. I mean, you can have, but you should not have. That is not the best practice. So it's good to have a composite index. However, you should not have, like, if you for example, if you have a table having 8 columns, right, and you create another an index in that table having 7 or 6 columns, that doesn't make much sense. Why? I will explain that in some different video with example. I think I have done that, but I will again cover it. So if you have a table in my previous example with 56 columns, and you have a index of say 8 to 10 columns, so an index means when you create a non-clustered index, that means it is having separate storage, right? It's not having exactly same storage what you are having for data page. So clustered index is the table itself, and then you have index, non-clustered index. So it is having separate storage, which is having subset of column. So basically in the index you will have less number of column, higher number of rows compared to data page of the table, right? That will have higher number of rows, a higher number of column with less number of rows. So locking an index will have bigger impact than locking a data page. Data page, what I am saying, not the data page of locking, but the page of the table at the leaf node, right? So if you have all page, so it will have more impact with the locking of index page than the data page on the table itself. Okay, however, both the things are having exclusive locks, so it is not a good thing to do. It is a good thing to do when you have an environment where you do too much of write operation, okay, and read operation is very, very less. So in the OLTP environment, it is it is not really preferred to have all page. Now I will come to data page. So in the data page, as I said, so the data page is having exclusive lock, but the index page will be having latch. Okay, it will not have exclusive lock. So that is the benefit from all page. Now, if you go data row is even better than data page, because you will not have exclusive lock neither on the data page nor on the index page. So it will be having latch on the data page and also on the index page. That is how it is. So the duration becomes very, very less, and it becomes easier for your insert operation, delete operation to perform without having any contention. That is how it is. So first thing, you have to enable the deadlock checking. The moment you enable it in your environment, you will see that deadlock details are getting printed in the error log. Then you check what is it, which one is victim, which one was not killed, and which one really went through. So for which one is committed, which one is rolled back, you will have detail of victim, you will have the process, you will have other details also, it will have SPID and all. And then if you are checking it and that time it's happening, you can use DBCC trace on 3604 and you can see DBCC SQL text pass the SPID, you can see the text of it. Although it will be printed in the error log. So you can analyze that. If it is not your query, it is application query, you can ask them to look at it. So by fixing deadlock, you will not only fix deadlock, rather you will be fixing the issues of blocking also. Okay, so this is something which you need to understand. So this way you can improve the performance of your environment by multifold. You can check yourself. Now second thing is about Sysmon. You should be running Sysmon in your environment when there is no significant amount of work going on or significant load is there. That time we run Sysmon for 5 or 10 minutes. I suggest to go for 10 minutes. And that time there is some segment you can see task context switches due to. Okay, in that you should focus on the cache miss. So cache miss, you should see how much it is. It comes in the value of percentage. So if the percentage is more than 5% or 10%, I have seen an environment where it's more than 80%. So you can imagine how bad it is. Higher the percent, worse it is. Okay, so it should be very, very less. So when you see that there is a significant amount of cache miss, you should go and check the like data cache segment, default data cache. Do you have any named cache? What is the partition and all that? If you go to that segment, cache segment, which will be below, you can see the spin lock also. But I will not get into spin lock right now. Like how can you fix another thing? But this is something which comes second for you. I mean, this is all basic thing which I explained about the performance tuning. So if the cache miss is really high, then you should go and check what is the cache miss for default data cache and if there is some other named cache also. So if there is anything which is high, you can see there is another segment. You will see it will also print the recommendation to that, right? Do you want, I mean, do you need to add any more no pool in that, or you need to change from LRU to MRU or something like that, it will be printed. So that is second part of that. So once we have more detailed analysis and explanation, I will provide detail how to fix that. But if you manage to find that, and if you take this to senior DBA and see like how it can be tackled, that will be good. So only these two basic things which I wanted to cover today. But in the handling deadlock, if you can manage to change the locking scheme of certain table. Now one more thing which I had to cover, that is heap and table. So try to have less heap in your environment than table, right? What is heap? Heap is a table which does not have clustered index. Okay, so you can have a table which can have primary key, but the primary key may not be clustered. It could be defined as non-clustered. So any table which does not have clustered index, so clustered means physical order of data, right? I think I have covered this in my previous video. I will give the link of that as well. So you have a table which does not have clustered index, that means it's a heap. And you can have primary key which can be defined as a non-clustered, and you can have a non-primary key which can be defined as a clustered, but there is overhead of that. So you should go with the best practice, which is having a primary key defined as clustered. So if you have a table which does not have primary key or you do not have clustered index, I'm just using interchangeably, but it's not actually interchangeable. So if that is the case, so it suits very well when you have an environment where you do too much of write operation, okay, not so much of read operation. So in the case of OLTP, you should be having more tables than heap. So in the Sysmon, if you go through the Sysmon output, you will see there is APL insert, okay, APL insert is there, and APL operation you will be seeing that. So try to analyze that part also and see. I mean, again, going back to deadlock thing. So once you have deadlock and multiple deadlock, try to fix that. While you will be fixing the deadlock thing, this APL thing will also be taken care by on its own, because you are changing the locking scheme there. Okay. Now two things I covered. One more thing that I wanted to cover here, which is again performance, which is again part of performance tuning, which is index hint. I have seen in many environment. I have been supporting managed service now, so we are supporting around 22 clients right now across the globe. Okay, so I have seen many client, and they're very well reputed names, and I mean you can uh, kind of, they are like world leaders in their own field, right? But I see there are many index hints used, and I have proved it to them that index hint is not something which you should use. I'm not totally against it, but it should be very used. I mean, it should be used in maybe 5 to 6% or max 10%, not more than that. If there is really a huge difference in data distribution, that's when you should be using index hint. In normal case, no. You should go with the optimizer. You should trust your optimizer that what index it will choose will be the best one. If the optimizer is not going for the index that you think it should be using, check the logical read, check the CPU time, check the elapsed time, check the plan. Maybe you need to have another index. I have myself, I have created few index which is much better than what they already had. Okay, try to go for composite index than having a single column, or not like two column index. The first column, as you know, in index is very important and crucial. So always go for the most selective column as the first column, and the one which is not a key updatable column, right? So you should go for first column as a column which is more selective but less less frequently getting updated, right? So few things are there. I can cover another video for index, like how to design an index and how to make it more effective, and how can you eliminate index hint. Index hint is something which you should not be using unless and until you know your data very well, and this falls in that 10% where data distribution is very uneven. If it is even, go for a basic I mean, you don't need to do any hinting, it will work on its own. Okay, so I covered 3-4 things today for performance tuning. First is deadlock. So first is enable deadlock checking, then go through deadlock in the error log, analyze the tables involved in deadlock. If they are having all page or data page, change that to data row. Or if, I mean, data page to data row is something which you need to really see, is it really required? But in some case it is required. Okay, and third thing which I said is heap and table. So if you don't have a cluster index on table, try to create one. But having cluster index, you need to know what is the primary key, which one is unique columns and all. And then fourth one that I explained about the index hint. So try to cover all these things in your environment. Try to implement them one by one in your UAT or test environment. See how it works. So take the deadlock detail from the production, because you may not have much deadlock in your test environment or UAT environment, and then do that change. Take the select statement, check the logical read, physical read and time in the UAT or test environment, create your index, change the thing and see how it works. Not only select statement, but the update or insert or delete operation as well, and see how it makes difference in your environment. Get the approval from whichever it is, okay, and implement it and see how the difference it will create in your environment. Okay, that should be all for now. So thank you very much for watching, and I'll be having more videos recorded very soon. As I said, I am having questions ready for application. I'll be covering that very soon. So thank you again, and as I requested earlier, if you like my video, please do like, and if you want me to cover something else, or if you have any question, do comment. And if you want me to cover more and more videos and come up with some other thing, do subscribe and share with your friends. Thank you very much. Appreciate watching. Thank you very much.